So we are here in jolly old England with Jake England here from Millennium Machines, and while this is an additive manufacturing event, you can't have additive without subtractive, because that, I don't know, whatever. Sure, we'll go with that.
We're always the odd ones out.
There's always somebody a little
weird,
a little different.
Yeah.
Okay, so what do we got here, Jake?
So Millennium Machines, we're known for our Milo CNC machines. We have actually brought a kind of timeline of all our machines. So we started the first big public release with V1.5, so that's the grandpa at the moment, the old Unk, right? And then last year we introduced a V2, right? Now unfortunately we couldn't save the frame from V1.5 to do the stuff that we wanted to do with V2. So we mentioned that we might be doing a V1.6 just to keep the people who did own a V1.5 happy. Over here we have le V1.6, right? Okay. So this is still in beta at the moment. It uses the same frame, the same rails, the same screws. The only real difference is the plates on the X, Y, and Z axis. These are now the updated ones that are on V2. It has the front way cover, but it doesn't have the rear way cover because we couldn't fit it. And you lose a little bit of X travel. But 90% of the big costs are still saved from the V1.5. Right?
Okay. And just for the record,
yep,
this is EVA 01 colors, not Joker colors, right?
Yeah, EVA 01.
Yeah, okay.
I didn't want to feel depressed with Evangelion. Right, on top of that, we had a little bit of feedback from last year about having the electronics under V1.5, and we agree. So, in the meantime, if you don't build a CASA and put all your electronics in CASA, we do have a universal electronics box now. Okay. Now that has everything that you need to build a Milo. It has the E-stop on it, it has keystone jacks, so if you want to build a Pi in there, you can. It has space for the driver boards, power supplies, everything you need to get any machine going. And because it's universal, that's the universal bit of universal, you can put it on any machine. It doesn't need to be a Millennium product. If you have an old router that needs updating and you don't mind using RepRap firmware, you can buy that and stick it on it. If you have an old VMC that you need updating and you don't have this one resistor that they stopped making in the 1950s, right? You can update it with that and it will work. Other than that, we have continued the tradition of Smurf in bringing partially made machines, right? So we had the old Y-axis for Atlas last year, but we kind of pivoted with the design. I'll send you some renders of the finalized machine. This is now the new Y-axis. It's going to be more router style. So there's going to be two of these, and we're looking at aiming at a machine that's going to be 150 kilos, which sounds like a lot, but every individual sub-assembly is going to be 30 kilos or less.
Okay, so you will be able to manhandle it by yourself.
You can build it as a single person. We've also got the Z-axis. We're aiming to have everything be 20 mil plate or 10 mil plate.
That is a beefy chunk of metal.
HGR 20 rails, you'll see them at the front over there, and we're using 1610 ball screws. One of the things we found out with V2 Milo, we did have a ball screw version, we still do have a ball screw version of V2 Milo, is that if you're running them with steppers, because they tend to have a lower lead, they're a 2mm lead rather than the lead screws which are an 8mm lead, you end up running out of torque on the steppers by the time you get to the feed rate that you want.
Okay.
Yeah. And if you think about it in terms of CNC machining, if you're going from a single flute tool to a 3-flute tool, you need to be tripling the feed rate. You can also do some other things like lower the RPM down, but tripling the feed rate is the most effective, and you can't do that with the small ball screws. So specifically on Atlas, we're going with big chunky 1610s. So these are 10 millimeters per revolution of the ball screws. They're chunky. And another great thing about Atlas, because it's a router style machine, you can build it in whatever size you want. The machine I'm building at the moment is, in terms of build volume, 350 in Y, 470 in X, and 145 in Z. Right? But it's easily expandable to whatever size you want it to be. The only reason I built it like that is because that's 200 millimeters smaller than the CASA enclosure is for Milo.
Okay.
So despite the fact that you're actually building a smaller enclosure, and it's a self-enclosed machine like a Voron would be, you're getting a whole lot more space.
Nice.
Now, a lot of people will look at us and go, why the hell are you building a router? A router's not meant for metal work and stuff like that. The reason we're going with a router is because of that versatility and ease of use for people. And the way you get around having geometric constraints is by making it big. Yeah. So if you think about it, if you look at something like a Print NC, which has an 80mm tube steel gantry, when you double the width of anything, you're actually 8 timesing its stiffness in that direction.
Yeah, square cube law and all
square
that.
cube law. If you do the maths for it, because we're stacking 2 80mm extrusions on top of each other, we've still at least quadrupled the stiffness of a steel Print NC, for example. Because a Print NC is built more of a router than anything else, it's not really designed to be stacked that high.
Okay.
Whereas we're designing specifically for that. Yeah.
Now we have some other stuff here. This is a cool little pendant.
We have loads of accessories this year. So over here we have our pendant. Right, I'm going to get Phil to operate this because I can't operate it with one hand. So on the side over here we have a dead man switch. Right? If you want to operate this machine, you need to be, if you want to jog it around, you need to be holding that. If you want to pass out, you drop the pendant, anything
or
like
you just
that.
bump it.
Or bump it, right?
It doesn't do anything?
It won't work until you press the button, select your axis, select how far you want to spin it, and then you can move an axis.
Oh, okay. That is actually extremely clever and smart.
Yep. So we are waiting for Duet to release a new screen at some stage, so you don't have to put the Raspberry Pi in it. But we still probably will release the Raspberry Pi version.
Okay, so this is running on a Raspberry Pi right now?
Yeah, running on a Raspberry Pi, and it's just a Raspberry Pi screen.
Okay.
And it just sends it straight to the Siler boards.
Oh, nice.
Yeah. On top of that, we also have the 4th axis over here. Now, this has been Phil's little beauty of a project. So
this is a DIY 4th axis.
This is a DIY 4th axis.
Okay.
I'm going to hand over the mic to Phil so that he can explain everything to you.
Okay, so what do we got here, Phil?
Sure. We've got a 4th axis that's been basically, with a few parts, machined on Milo itself. So you will need to buy the motor and the rotary axis, and of course your selected work holding. In this case, it's just a self-centering vise. And all the plates and everything has been milled in Milo. So it's basically the DIY RepRap project again. And can hold up to, this is 50 by 50 millimeter aluminum stock. And yeah, you can do positional 4th axis work. And if you have the big manufacturing extension for Fusion, you can also do simultaneous 4th axis.
So we'll head over to the other side of the table now. 9 unfortunately couldn't make it today, so I'm going to have to act on 9's half. So Siler is limited to 4 axes.
Yep.
Now,
what is Sila?
Siler is the control board that BTT makes for us.
Okay.
You're also using it on the Voron team, I think, for the Cascade?
Yes, I believe.
Yeah, you're using it on the Cascade. But we partnered with BTT last year to make that. But Siler only has 4 axes. So you got an X, Y, Z, or if you're looking at Atlas, you're going X, Y, Y, Z, right? You're going to run out of ports eventually. And it's really, really hard to find RepRap configurable, RepRap firmware configurable CAN boards that aren't made by Duet and are really expensive.
Yep.
And none of them are designed for CNCs.
Okay.
They're all designed for 3D printers.
Okay.
So what we have over here is 9 Miles' little project where he's made a CAN board specifically so that if you need an extra motor, if you need it for the tool changer, because both of our tool changers require an extra stepper. So if you're running a 4th axis, you'll need one of these just to run the tool changer as well. Right? But if you look at the back, there's a little nubbin, a little breakout. So we're planning to add FOC control, so field oriented control, closed loop stepper support.
Oh, nice.
So you can just bang one of these on the back of a stepper, be it NEMA 23 or NEMA 17, right? And then you can get FOC on those motors.
Nice.
Yeah? And it has all the standard outputs that you would want, and it's CAN FD, none of the old weird clipper CAN that kind of works and kind of doesn't half the time. And then over on this side over here, we've got only one of our tool changing modules. So this is called the 4-pack, and I'll pass it over to Alan, and he can explain the rest for you.
Hello.
Hello there.
So this is the 4-pack. This is, I got all fancy. This is one of our tool changers. There is another one called the Spice Rack that is a turret style. This is designed to use one of the N17 boards is in the back here, so you just run one of the standard XT30+2 connectors in there, and that drives the NEMA 8.
So you can't fly those.
That will open and close the lid as well as provide our end stop there, so the system knows when this is positively closed, so you don't wind up running operations and getting...
Oh, so that'll keep all the chips out and all that.
Yeah. So this would just open up, you'll move over, swap your tools, and then close that.
What are you using for grabbing and letting go of the tools?
That's done directly from the spindle. So the way these units work, here, let me see if I can pop one out. So this has compression springs in it. So the collet nut actually goes down, engages with that, and then there is a compression wave spring. So once this has enough downward force on it, as this is spinning at a low RPM, I don't know if I'm going to be able to do it one-handed, but those teeth at the bottom actually engage. So you'll run the spindle reverse to unthread, move over, run it.
Oh, so you're basically, it auto unscrews and screws in the new one. Okay.
Yeah, so it's only from the pressure from the spindle moving in Z.
Oh, nice.
Yeah.
That is really cool.
So hoping to have this ready to go when the LDO kits are available this summer.
Awesome. And just to finish things off, because I know everyone in the comments is going to ask when things are going to be ready, V2 has been released for a while. We're still waiting on kits. They should be coming out later this summer. Hopefully, that's what we've been told by LDO. V1.6 is currently in beta form. You can buy the parts for it online and take, like I said, 90% of the V1.5 parts and just convert it over. Atlas is still a work in progress. We're still working on getting the budget just to build it.
Yep.
If you're wondering what the budget's going to be for a fully complete kit, I'm estimating somewhere between $2,000 and $2,500/pounds. Yeah. So it's all in the works. It's being done. My team's done an amazing job this year. Honestly, this Smurf has been made by them, not by me, and that I honestly cannot thank you guys enough for it. It's been awesome. So yeah, that's everything I have to talk about. Anything else you want to know?
I think that's about it.
Perfect. Have a great rest of your Smurf.
Yeah, cheers.
Cheers, man.
Content from this year's Sanjay Mortimer Rep Fest is sponsored by LDO Motors. For printer parts, kits, accessories, and more, check them out at the link in the video description.